Inverse of matrices. What is an inverse? If I take a value A and operate this with B and I get an identity element or identity, we say B is the inverse of A. So any matrix, say represented like this, the inverse, when inverse is applied to that matrix, that is, you actually multiply them, you should get a matrix which is called as the identity matrix. Identity matrix. So A multiplied by A inverse should give you identity matrix, and this is the inverse of the matrix. So matrix A, it is non-singular. What is a singular matrix? The singular matrix is that value, the determinant should be 0. Non-singular, the determinant is not 0. So how do we write it? It is invertible. If we have a A matrix and a B matrix, when you multiply it, you will get an identity matrix of the same order. Same order. So this, I'll just show you what is happening here. 1 into 2 by 3 plus 1 into 1 by 3, this is the first element. 1 into negative 1 by 3 plus 1 into 1 by 3, this is the second element. Negative 1 into 2 by 3 and 2 into 1 by 3, add them. Negative 1 into negative 1 by 3, 2 into 1 by 3, add them. This is the element. So what do you get? 1, 0, 0, 1. This is the identity element. So this is the identity matrix of 2 by 2. So the inverse of 1, 1, negative 1, 2 is 2 by 3, negative 1 by 3, 1 by 3, 1 by 3. So the common notation of inverse is just A raised to the power minus 1. The inverse matrix A inverse is unique. That is, you will not have any other matrix that will be an inverse of a particular matrix. There will be only one inverse. So if you take the inverse of an inverse of an inverse, you get the original matrix back. Okay. And if A is an invertible matrix, then A transpose to the power minus 1, that is inverse of transpose, is simply equals to the A inverse transpose. That is the same thing. Okay. First you take inverse, then you take the transpose.